Hi again. Today there is some information about the Tesla coil and the field sensor. I put an extra switch to reverse polarity of the microampere meter. It's useful, and just detail the circuit following information gathered from other people that made a replica what Alexei is making, and this is my setup and information about the Tesla coil. It's very simple. The circuit must be simple. I tried to put extra capacitors and stabilizers and whatever to find the frequency. Actually, the best way for the frequency is to best way to change the frequency is just to move the primary L1 up or down, and has a small effect on the out frequency of the secondary. It's not too much. It is from 1.1 MHz to 1.6 MHz, with the self-resonance of the secondary coil around 1.250, 1.3 MHz. So you see, this is the movement of the coil up and down. Let's see what's happening. So we connect the power. Just make this connection here. This is 12 volt supply from an old computer. This is a regulator 9 volts to feed the frequency meter, which is very sensitive. Just if you touch the probe, gives you the 50 Hz environment frequency of the mains power supply. Okay, so I connected close to the high voltage lamps, which are directly to the Tesla coil exit. I'll switch on the Tesla coil. Make Tesla coil on and off. Okay, so this is on. Frequency is 1277 MHz, and if moving the coil down is increasing the frequency, 1.5 MHz, but it's less power to the lamps because it's not close to the self-resonance of the secondary. So I'm moving up the L1, see what's best output. So self-resonance supposed to be 1.29 MHz with free core. Now there is a cable connected to the Graviflyer down here. This is for the frequency of the Tesla coil. to adjust, I'll put the cable inside the Tesla coil. Frequency drops to 1 megahertz. This means it's changing the self-resonance of the secondary to 1 megahertz. See, it's coming the maximum output according to the lamps, and is transmitting the frequency to the whole body of Graviflyer. So I'm giving more sensitive to the field meter. And when it's removed the lamps, so I'm touching these two cables here to have the frequency measurement. Because off scale is quite strong, the Tesla. Actually, if you touch active parts of the circuit, gives you some burns here and the top of the coil here, and of course the top of the Tesla. So let's see the field transferred to the Graviflyer. It's good. I'm touching, so I absorb the field. It's not harming, but it's not supposed to stay in these fields long time. So let's see what's happening with the frequency when the coil is moved up or down. It's transferred the field, it's not losing, it's actually quite strong. Should be enough to start the device. And moving the primary full down close to the base is 1.2 megahertz. I'm moving up. Goes to 1 megahertz and still transferring the power So it's working the transfer of frequency from the Tesla 2 meters across to the device. The device has, I put some magnets on the top of the construction to keep the strength. I put some extra magnets on the top to keep the strength. So the frequency is 1.2. The adjustment of Tesla frequency going out to the Graviflyer should be adjusted only using the secondary long coil, which is 41.5 centimeters and 3.9 millimeters diameter. This one. 3.9 centimeter, 415. There's a formula that gives you an estimate before the construction. Actually, if you have less turns, less than 870, you have less, you go up in frequency. So according to what will happen when the whole system takes the power, I will adjust the secondary long coil to be self-resonant with the cable out, this cable out, to match what's needed to make it fly. That's it for today. See you.